Hi there, folks. Today we're looking at writing linear equations in point-slope form. All right. So the first thing we need to remind ourselves about is what point-slope form is. Remember, point-slope form is the one where it would give us an ordered pair that's on the line, and the slope. And when we were graphing these things, it was basically giving us a point to start with, and then we'd use the slope as the pattern to get to the next point. Well, now we're going to be given those two things or be able to find those two things. Then we want to go back to writing the equation. All right. And there's a couple of things, remember, with point slope form, m is the slope. All right. So that's the easy part. Where we see the m in the equation, that's where we just plug our slope in. But then x sub 1, y sub 1 is the point on the line. All right. And keep in mind that when we've read this point, all right, when we were looking at point slope form, this minus sign is like the opposite of the y value. This minus sign here means like the opposite of the x value. And so as we write the equation, if we have the point that's given, when we write the equation, we do the opposite of that value, all right? Just like when we had the equation, we did the opposite of that value to write the point. Now when we have the point, we do the opposite of that value to write the equation. Again, when you see a minus sign in a formula, think the opposite of that thing, all right? Minus signs mean opposite signs, especially when we're talking about mathematical formulas, okay? For example, if I look at something like this guy, it says write an equation of point slope form of the line that passes through the point 4, -3 and has a slope of 2. And so once again, if I think about point slope form, that's y minus y sub 1 equals m times x minus x sub 1. And once again, as I write this thing, the y value here, the one that says y is just y. Same thing over here, the one that says x is just x. But now remember, this guy, this is our ordered pair. There's the x value. Here's the y value from the ordered pair. But again, that minus sign means the opposite of that value, all right? So when I look at this guy, here's the x value. It's a positive 4, so the opposite of that would be a negative 4, so I write a minus 4. All right. And notice if you kind of read that backwards, when you see x minus 4, you see a minus 4, which means the point is a positive 4. Okay. So whatever the point is, just make sure you have the opposite value there. Same thing here. This is a negative 3. So in the equation, instead of being a negative 3 or a minus 3, it's going to be a plus 3. It's the opposite of that point. All right. And then the slope, we just plug in for m. Here's my slope. It's a 2. So that's what goes right here, 2. And that's it. All right, so writing equations in point slope form, this is the easiest way to write the equation of a line. We just have to remember that those minus signs are built in, which means I do the opposite of whatever the point is. Okay, and that's it. If I look at the next one, it says write an equation in point slope form of the line that passes through the point -1, 4 and has a slope of -2. So once again, point slope form is this guy. And this is my y, this is my x, and now I just plug away. Ready? I look here and say, oh, I see a -1 for my x value. So in my equation, it's going to be the opposite of that, so I'm going to put a +1. Up here, I see a positive 4 for the y value, so in my equation, it's going to be the opposite of that, so it's going to be a -4 in my equation. And then up here, I see the slope is -2, so in my equation, I just write a -2. The slope is literally the same thing as whatever the slope is. Only the points have those minus signs in the formula, so only those I turn into the opposite. And that's it, okay? Plug in the point, plug in the slope, and we're done. Okay? If I look at the next one, all right, same thing. Except this time, they don't just outright give me the slope, and they don't outright give me a point. All right, I have to find those things. I still want to do the same stuff, so it's still y minus y sub 1 equals m times x minus x sub 1. But now think about it. I need a point and I need the slope. A point on the line, well, that should be fairly easy. I just have to look around here and find a point that this thing goes through. Maybe I'd choose something like this guy right here. It looks like it goes through the point -1, -1. And so write that ordered pair down. Ready? If I write that ordered pair down here, that's -1, -1. So now as I plug it in, the opposite of that x value is going to be a +1, so I put a +1 over here. If I look at the y value, the opposite of that is a +1, so I put a +1 over here. Remember, it's the opposite of those values that go into the equation. But now the slope, I have to actually find the slope, so maybe find another point that this goes through. See, it goes through this point, it goes through this point, right? So use the rise over run. Think about the pattern here. So if I think about the pattern that emerges, To get from one point to the next point, I have to count up to 1, 2, and then over 1, 2, 3, 4, 5. So it's up to over 5, so my slope is 2/5. Okay? And remember, that's just the pattern, rise over run. Go from one point to the next. How far up do I have to go? How far over do I have to go? So that's a 2/5. So here we go, 2/5. And that's it. And keep in mind, there are multiple answers that would work for this particular line, because there's multiple points I could have used. Let's say, for instance, that I use this point back here. That's the ordered pair 1, 2, 3, 4, 5, 6. This is the ordered pair -6, -3. So I could have had the equation like this. The opposite of that y value, that's a +3. The slope is still the same. The opposite of the x value, so that's a +6. These represent the exact same line. And because there's an infinite number of points on this line, there's an infinite number of equations that I could write. Maybe I would have used this last point. Look at this, 4, 1. So if I'd used the 4, 1 here instead, again, the slope doesn't change. But now the ordered pair, the opposite of the 4 is a -4. The opposite of the positive one is a -1. And so I could have used that third ordered pair instead. So keep in mind that there are multiple answers. Notice the slope has to be the same no matter what, okay? If it's representing this line, it has to have a slope of 2/5. But depending on which point I choose will change the equation, all right? And that's a good thing because, again, it makes the equations really easy to write because there's lots of different ways that I can come up with the ordered pair that's on the line, okay? The difficulty here is that I might write one equation, you might write another, and even though they don't look the same, they represent the same line, so there's not as much consistency there. But keep that in mind. Any one of these answers would be fine. And again, this line keeps going. There's more ordered pairs that you could choose from, okay? If I look at something like this guy, it says, give a line that passes through the points 2, 3, and 4, 4. Write the equation in point-slope form. And to be perfectly honest with you, this is as difficult as it gets. Right here, if you can do this example, you can do them all right? This is as tough as it gets. And so once again, I need two things. I need a point and I need the slope. So I've got y minus y sub 1 equals m times x minus x sub 1. That's the equation that I'm looking for. And I have a couple points here. Like if I used the first point, 2, 3, the opposite of that 2, that's a positive 2, so I'd do a -2. Instead of a positive 3, I would do a -3. But now the thing that I'm missing is the slope here. Well, I know how to find the slope when I'm given 2 points. That's my formula. Remember the second y value minus the first y value? Over second x value minus the first x value. And so I have to plug these in. The second y value is a 4 minus the first y value is a 3. The second x value is also a 4 minus the first x value is a 2. And so this is 1 over 2, so that's a 1/2. Now I have the equation of my line. Okay? And again, I didn't have to use that first ordered pair, the 2, 3. I could have used the second ordered pair, so I could use this as the equation as well. Ready? The 1/2 is still going to be the slope no matter what. But instead of using the 2, 3, I could use the 4, 4. So a -4 and a -4. Remember the opposite of each of those. So either one of these would be an acceptable answer. But I have to find the slope doing my slope formula. And that's what makes these more difficult. Getting the slope from a graph is easier. It's easier to just count rise over run. Okay? Finding the slope with 2 points is the most difficult, which means this is as tough as these problems get. Okay, so find the slope using your slope formula, and then when you plug in the ordered pair, make sure you do the opposite of each of those values. If I look at something like this guy, again, same kind of thing. And see, now that I've done one of these, I know that I need to find the slope, so maybe I start off with that, okay? And so here I'm going to do point slope form. I need to find the slope first, so let's do my slope formula. Second y value minus the first y value over second x value minus the first x value. The second y value is a 9 minus the first y value is a 5. The second x value is a -3 minus the first x value is a -1. And be careful with that minus and negative thing. Remember, subtraction is the same as adding the opposite. So that becomes -3 plus 1. So here 9 minus 5 is a 4. -3 plus 1 is a -2. And now 4 divided by -2 is a -2. That's my slope, all right? And now if I'm using my formula, my point slope form, remember it looks like this. So there are two versions of the equation I can write. Let me put them over here. I could use that first ordered pair, or I could use the second ordered pair. If I use the first ordered pair, the slope is still -2 no matter what. But now if I look at that first ordered pair, the x value is -1, so here I would put a +1. It's the opposite. The y value is a +5, so here I'd put a -5. It's the opposite. That would be an acceptable answer. And you don't need to do the other one here, but in case you had chosen the second ordered pair, here's what it looks like. Ready? Slope is still a -2. That one doesn't change. But if I use the second ordered pair, the x value is a -3, so I'm going to put a +3 here. It's the opposite. The y value is a +9, so I'm going to put a -9. It's the opposite. And that would be an acceptable answer as well. Okay? So again, any one of these is acceptable as long as you use an ordered pair that's on the line. It doesn't matter which one you pick. Okay? And so if you kind of look at something like this, we have other forms of the equation that we know about. There's standard form and there's also slope-intercept form. Let's talk about slope-intercept form for a second. If I took the previous equation and put it in slope-intercept form, let's say I took that first one that I have written down. If I want to put this guy in slope-intercept form, remember all I have to do is solve for y, get y by itself, which is 2 steps. I use my distributive property. We've done a couple of these in the past. So I distribute, that's a -2x minus 2. And then I add the 5 over to the other side, getting y by itself. So what that gives me then is y equals -2x plus 3. So that's the equation in point slope-intercept form. So I convert it from point slope. But let's say for a moment that I used that second equation instead. Ready? What if I used the y minus 9 equals -2 times x plus 3? If I want to, sorry, that is a terrible looking 9. I can do better than that. I believe in me. Okay? If I want to put this thing in slope-intercept form, it's still the same 2 steps. I still have to distribute. So that's y minus 9 equals -2x minus 6. And now I have to add the 9 to each side. And so what I end up with is y equals, in blue, of course, red. That's crazy talk, right? Y equals a -2x plus 3. And if you look, I got the same equation when I used the other version, right? The difference here is when we talk about point slope form, there's any number of equations we can write. I could use any point. But when we talk about slope-intercept form, there's only one point that's going to work, and that's that plus 3. Remember, that represents the y-intercept, okay? The difference is that with point slope, there's an infinite number of equations. When you do slope-intercept, everyone's equation is going to be the same. There's only one version of the equation for slope-intercept form that will represent that line. Okay, and so if you haven't guessed it by now, the next lesson we're going to look at is writing equations in slope-intercept form, which, spoiler alert, based on this last question, you already know how to do. Okay, the advantage of slope-intercept form is that all of our equations will be the same. There's more consistency there. Okay, it's not as easy, all right, but there's more consistency. So writing equations in point slope form, super easy. We need the slope. We plug the slope in for m. And we need a point that's on the line. And just remember, when you plug those points in, there's a minus sign built in the form, which means you have to do the opposite of each of those values, okay? And that's it.